Exercise 7.1, question number 13. Out of 750 families with 4 children each, how many families would be expected to have at least one boy, at most 2 girls and children of both sexes, assuming equal probability for boys and girls? So 2 children, that is either boy or girl. Out of that, probability of boy is 1/2, probability of girl is 1/2. Question itself mentions they have equal probability. That is, we are avoiding transgender. Now, this 750 we will multiply at the end of the question. So, ignore this. How many children each? 4. N is equal to 4. Next one, we need to have at least one boy. So, having known N, P, Q, let us consider X to be number of boys. We know the probability function for binomial. At least one boy tells me X is number of boys. So, X greater than or equal to 1. I can find out 1, 2, 3, 4 or 1 minus what I don't want. What I want is at least one boy. That is 1 boy or 2 or 3 or 4 boys. So don't want is X is equal to 0. Subtract from 1. 1 minus, put 0 here, N is 4. 4C0, half power 0, half power 4 minus 0 as I substitute in the distribution. 4C0 value is 1. Half power 0 is also 1. I am left with half power 4. What is half actually? 0.5. So 0.5 power 4, let us find out. 0.0625. 1 minus 0.0625 gives rise to 0.9375. This is for one family to have at least one boy. My question is 750 families. Multiply by 750 and write the answer. It is 703.125. It is number of families, so avoid decimals. Approximate to the whole number, which is 703. So 703 families will have at least one boy. The second question, at most 2 girls. X I have taken number of boys. If I say at most 2 girls, there will be at least 2 boys. At least 2 boys tells me X greater than or equal to 2. We have taken X as boys. When they say at most 2 girls, there may be 0 girls or 1 girl or 2 girls. Accordingly, you find out the boys. There are 4 children. 0 girls means 4 boys. 1 girl means 3 boys. And 2 girls tell me 2 boys. So find out all this. In the formula, put X is equal to 2. I get 4C2 half power 2 half power 4 minus 2. Similarly, 4C3 half power 3 half power 4 minus 3. And X is equal to 4. 4C4 half power 4 half power 4 minus 4. In all the cases, I get half power 4 only. Plus 2 minus 2 cancels, plus 3 minus 3, plus 4 minus 4. So I can take half power 4 out. What is left out? 4C2, 4C3, 4C4. Simplify this answer. Half power 4 is 1/16. 4C2 value 4 into 3 by 1 into 2. 4C3, 4 into 3 into 2 by 1 into 2 into 3. 4C4 is 1. Add all this answer. Divide by 16. Find out the probability. For one family with at most 2 girls is 0.6875. Therefore, for 750 families, multiply by 750. 750 into 0.6875. 515.625 approximated as 516. So 516 families will have at most 2 girls. Third part of the question, children of both sexes. That is, the family should not have all 4 to be girls or all 4 to be boys. So, there may be 1 boy, not 0 boys, because both the sexes must be there. So, there may be 1 boy or 2 boys or 3 boys. So, put x is equal to 1 in the formula. 4c1 half power 1 half power 4 minus 1. 4c2 half power 2 half power 4 minus 2. 4c3 half power 3 half power 4 minus 3. In all the cases, half power 4 will come out. Plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 cancels. I am left with 4c1 plus 4c2 plus 4c3. Simplify this answer. 1 by 16 into 4c1 is 4. 4c2 is 4 into 3 by 1 into 2. 4c3 is 4, 3, 2 by 1, 2, 3. Cancel and simplify the answer. So we get 1 by 16 into 10, 4 plus 6, 10 plus 4, 14. So we get 14 by 16. For one family, it is 7 by 8. Therefore, for 750 families, multiply 750 into 7 by 8. 656.25 or approximating 656 families. So, the question is about a family with 4 children each. N is equal to 4. The very first line of the question says 750. We will multiply in every last step. And they have given about boys and girls having equal probability. So, P and Q are half. Taking X as a number of boys, at least 1 boy, X greater than or equal to 1. At most 2 girls tell me it is at least 2 boys. So, it is X greater than or equal to 2 and children of both sexes tell me not all 4 are girls, not all 4 are boys. So, there may be 1 boy or 2 boys or 3 boys which we have substituted. Take and write the answer in whole numbers as we are doing number of families. Exercise 7.1, question number 14. 40% of business travelers carry a laptop. Out of 15 such travelers, what is the probability that 3 will have or 12 will not have or at least 3 have laptop? Let us consider the question is about carrying a laptop. So, X is the number of travelers carrying laptop. P, probability those who carry is 40% which is 0.4. Q will be 1 minus P that is 0.6. Out of 15 such travelers, so N is equal to 15 and we have written the binomial distribution. The very first question is probability 3 will have laptop. That is P of X is equal to 3. In the formula, let us substitute. Wherever X comes 3. N is 15C3. P value 0.4 power 3. Q value 0.6 power 15 minus 3. 15 into 14 into 13 by 1 into 2 into 3. 0.064 and 0.6 power 12. As we use our calculator, we get 0.0634. Second part of the question is probability 12 will not have laptop tells me 15 minus 12 will have the laptop. 15 minus 12 tells me 3. So, it is the same old answer. P of X is equal to 3, 0.0634. So, 3 will have and 12 will not have will have the same answer because the total is only 15. Third part of the question, at least 3 will have the laptop. The word at least tells me P of x greater than or equal to 3. That is 1 minus P of x is equal to 0, x is equal to 1, x is equal to 2. So all the 3 let us find out, add it, subtract from 1. So I want from 3 to 15. Finding 3 to 15 is difficult. Instead, 1 minus what we don't want. So on 3 up to 15 is difficult. So 0, 1, 2 which I don't want. Let me subtract from 1. 1 minus. Put x is equal to 0. 15 C 0. 0.4 power 0. 0.6 power 15 minus 0. Plus x is equal to 1. 15 C 1. 0.4 power 1. 0.6 power 15 minus 1 is 14. Plus 15 C 2. 0.4 power 2. 0.6 power 15 minus 2 is 13. Again 15 C 0 value is 1. 0.4 power 0 is also 1. Find out 0.6 power 15. 15 C 1 is 15. 0.4. 0.6 power 14 plus 15 C 2. 15 into 14 by 1 into 2. 0.4 square is 0.16. 0.6 power 13. So use calculator, simplify the answer. Each term separately find it, add it all, then subtract from 1, we get 0.9729. So probability at least 3 have the laptop is equal to 0.9729. Exercise 7.1, question number 15. A pair of dice is thrown 4 times. Here there are 2 things, so don't get confused. Pair of dice, we can immediately write down the outcomes 1, 1, 1, 2 like that. So there are 36 such outcomes. How many times it is thrown? That tells me n. So n is equal to 4. Getting a doublet is considered a success. What do you mean by the word doublet? Same number 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There are 6 possibilities out of 36. So probability of success is 6 out of 36, that is 1 by 6. Q is 1 minus P, that is 1 minus 1 by 6, which is 5 by 6. We know N, P, Q. Write down the binomial distribution and the question is find the probability of 2 successes. P of x is equal to 2. NCX 4C2. P power x 1 by 6 power 2. Q power n minus x 5 by 6 power 4 minus 2. Simplify the answer. 4C2, 4 into 3 by 1 into 2. This is 1 by 36. 5 square 25, 6 square 36. Use calculator, simplify the answer. We get 25 by 2, 16, which is nothing but 0.1157. Exercise 7.1, question number 16. Mean of a binomial distribution is 5 and standard deviation is 2. Determine the distribution. Mean of a binomial distribution, we know the formula, it is NP, that is 5. And variance, we know the formula, it is NPQ. Given standard deviation, I call it as root of NPQ, which is 2. Squaring on both the sides, NPQ equals 2 square, that is 4. Divide. NPQ divide by NP tells me 4 by 5, or I get Q equals 4 by 5. What is P? 1 minus Q. 1 minus 4 by 5, cross multiplying. 5 minus 4 by 5, that is 1 by 5. I know what is P and Q. Put it in NP. NP equals 5. N we don't know, but P is 1 by 5. Equals to 5 tells me N is equal to 25. So now we know what is N, what is Q and P. We know the distribution. Binomial, the formula is P of x is equal to x equals to NCX, P power x, Q power n minus x. X is from 0, 1 to up to n. As I substitute NCX, n is 25. C, x is not given, it ranges from 0 to n because we are writing only the distribution. P power x, P is 1 by 5 power x and Q is 4 by 5 power 25 minus x. X ranges from 0, 1, 2 up to n. What is n? 25, and that is my answer. So this is a question where we are identifying the distribution. Not P of x all that. Generalizing the distribution, just substitute NPQ in the formula. Leave x as it is and declare x is from 0 to n value. Here n is 25, so put 25. Exercise 7.1, question number 17. Determine the binomial distribution with mean 4 and variance 3. Same as the 16th problem. We know mean NP equals to 4 and variance NPQ equals to 3. As we divide, NP by NPQ equals 4 by 3, or I will say 1 by Q is 4 by 3, Q is equal to 3 by 4. Once I know Q, P is equal to 1 minus Q, that is 1 minus 3 by 4, 4 minus 3, that is 1 by 4. Put P value in NP. P is equal to 1 by 4. Let us substitute in NP equals to 4. So 1 by 4, N is 4 or N is equal to 16. What is the binomial distribution? We write P of x is equal to x is equal to NCX, P power x, Q power n minus x. X is from 0, 1 to up to n. As I substitute, P of x is equal to x is 16cx, 1 by 4 power x, 3 by 4 power 16 minus x. X is from 0, 1 to up to 16. My question is to find P of x is equal to 15. Substitute in this equation 16c15, 1 by 4 power 15, 3 by 4 power 16 minus 15. 16c15 can be written as 16c subtract. 16 minus 15 is 1. So what formula I use? NCR is NC n minus R. 1 by 4 power 15, 3 power 16 minus 15 is 1, 4 power 16 minus 15 is 1. Simplifying this, 16c1 is 16. 1 by 4 power 15 plus 1, that is 16 into 3. So 1 into 3, 3. 4 power 15 into 4 power 1 is 4 power 16. 16 can be written as 4 square by 4 power 16. 4 power 2, 4 power 16, you can subtract when we divide. So 4 power 16 minus 2, that is 14. You can use calculator and simplify, or to arrive at book answer, you can write the answer like this itself. 3 by 4 power 14. Exercise 7.1, question number 18. Assume that a drug causes a serious side effect at a rate of 3 per 100. So, serious side effect, we take 3 per 100. So, P is equal to 3 by 100. Immediately, I can write P equal to 0.03. Q is 1 minus P, that is 1 minus 0.03, that is 0.97. What is the probability that at least one person will have side effects? So, X is equal to number of persons having the side effects. Out of how many given? 10. That tells me N is equal to 10. So, we have written NPQ. X is the number of persons having side effects. My question is at least one. So, I need to find X greater than or equal to 1. What is the formula? It is binomial distribution. X follows binomial with parameters n and p. NCX p power x q power n minus x. X is from 0, 1, 2 up to n. Greater than or equal to 1 tells me 1 to 10 I must find out. So 1 minus p of x is equal to 0. Greater than or equal to 1 tells me 1 to 10. So what I don't want, I subtract from 1. 1 minus 10C0, 0.03 power 0, 0.97 power 10 minus 0. 1 minus 10C0, 1.03 power 0 is also 1, 0.97 power 10. Simplify the answer. We get 1 minus 0.7374, that is 0.2626. So, at least one person will have side effects out of 10 is 0.2626. Exercise 7.1, question number 19. 5 mice from a same litter suffer vitamin A deficiency. They are fed some carrots as dosage. The positive reaction is recovery from the disease. If the probability of recovery is 0.73, find the probability that at least 3 out of 5 recover. From this question, we say P, probability of success, is 0.73. Q is 1 minus P, that is 1 minus 0.73, 0.27. N is number of mice, that is 5 given. Question is at least 3 recover. So, X is equal to number recovers. My question is P of X is equal to X. It is a binomial distribution with parameters N and P. NCX, P power X, Q power N minus X. X is 0, 1, 2 and so on up to N. I need at least 3. The word at least 3 tells me X greater than or equal to 3. That is, X is equal to 3 or 4 or 5. Since there are 5 mice in the litter, X is equal to 3 to 5. Substitute in the formula, N is 5. 5C3, 0.73 power 3, 0.27 power 5 minus 3. 5C4, 0.73 power 4, 0.27 power 5 minus 4. 5C5, 0.73 power 5, 0.27 power 5 minus 5. 5C3 meaning 543 by 123. 0.73 power 3, 0.27 power 2. Now that you know very well, we can simplify this as 5C1. 0.73 power 4, 0.27 power 1. 5C5, same number comes, answer is 1. 0.73 power 5, power 0 also, my answer is 1. Use calculator and simplify. 0.2836 plus 0.3834 plus 0.2073. Each term separately we have to simplify. Adding which we get 0.8743. So probability at least 3 mice will recover. The answer is 0.8743. Exercise 7.1, question number 20. An experiment succeeds twice as often it fails. What is the probability that in the next 5 trials there will be 3 successes, at least 3 successes? The first line tells me success is twice, failure is once. So twice as often it fails. 2 plus 1, 3. So by 3, by 3. This we call P and this we call Q. Second line tells there are 5 trials. So 5 trials tell me n equals 5. So we say x is equal to number of successes. And x follows binomial with parameters n and p. P of x is equal to x is NCX p power x q power n minus x. X is from 0, 1, 2 up to n. My question is 3 successes. So 3 successes tells me P of x is equal to 3. NCX 5C3 P power 2 by 3 power 3 1 by 3 power 5 minus 3. 5C3 meaning 5, 4, 3 by 1, 2, 3. 2 cube is 8. 3 cube is 27. 1 square is 1. 3 square is 9. As you cancel, we get 80 by 243 or 0.3292. Second part of the question is at least 3 successes. So we write probability of at least 3 successes. The word at least, x greater than or equal to 3. There are totally 5 trials. So I can say x is equal to 3 or x is equal to 4 or x is equal to 5. Substituting in the formula for 3, 4 and 5. NCX 5C3 2 by 3 power 3 1 by 3 power 5 minus 3. 5C4 now 2 by 3 power 4 1 by 3 power 5 minus 4 is 1. 5C5 2 by 3 power 5 1 by 3 power 5 minus 5 is 0. 5C3 value, and you are thorough with now. Find out the answer yourself. Just check your steps as you try on your own. Your answer might be 192 by 243 if in fraction, or 0.7901 if you use calculator and simplify.